Number 45. Find the area of the region bounded by the curves y1 equals 8 minus 2x and y2 is equal to 1 over x. So let's actually graph both of these so we can get a little bit of a better conceptual understanding of what this is going to look like. So if I go to my calculator, I can make a graph page. And my first is going to be 8 minus 2x, which looks like that. The second one is going to be 1 over x, which looks like that. I might have to zoom out a little bit so we can see these intersection points. So yes, so we're looking for this area right here. So first thing we have to do is find these boundary points. And then once we find the boundary points, we can use an integral to find the bounded area. So to find where these intersect, all we have to do is just find when they're equal to each other. So in other words, 1 over x will have to be equal to 8 minus 2x. So we get bounds at 0.129 and at 3.87. And that looks pretty accurate. This is pretty close to the y-axis. And if we count 1, 2, 3, 4, it looks like that intersection is just a little bit before 4. So that checks out. So then to find this bounded area, just use the formula. For bounded area is going to be equal to the integral of these two boundary points. So 0.12917 to 3.8708. And then you're going to integrate the upper function minus the lower function. So on this interval, it looks like the function that's above during the interval is going to be 8 minus 2x, this blue part. So 8 minus 2x, and then the lower function will be the red, which is 1 over x. And so subtract 1 over x, derive or integrate with respect to x. So we get a bounded area of 11.6. So let's see what they want us to round to in our problem. 11.6, yes, the nearest tenth. Yeah, so that's our answer choice E. And a little bit about this. This may seem a little bit weird why we're subtracting these two things inside of our integral. But imagine you were just finding the integral as of 8 minus 2x, 8 minus 2x over this interval. So I'm going to actually draw this out. And this is going to be pretty rough, but I bet I can do a decent job. So 8 minus 2x will look something like this. So that will be at x equals 4. And then 1 over x looks something like that. That's not too bad. And so we know these intersection points are at A and B. I don't remember what they were, actually. Let's see. So 0.129 and 3.87. 0.129 and 3.87. So imagine we just integrated on the equation of our line of just 8 minus 2x. So we would be integrating of 0.129 to 3.87 of 8 minus 2x. And what would that area look like? That area would look something, these are our bounds, right? This area would look something like this, right? So just don't even worry about the 1 over x. That's what the area would look like. And then the reason we integrate 1 over x also is, look at this. Now if we integrate 0.129 to 3.87 of 1 over x dx, well, what does that area look like? It looks something like this, right? And so you can see, if we just take that full area that we found for 8 minus 2x and take out this area that we found integrating of just 1 over x, or just subtract them, right? Then we're left with this area, which is what we really want. So that's why you subtract. So if you take the integral from these two bounds of 8 minus 2x dx and subtract out the integral 0.129 3.87 of 1 over x dx, that will give you the bounded area. But that's not exactly what I did. And the reason behind that there's some proofs out there that have to do with like limits and such, but pretty much what they say is that you can actually combine these two under the same integral. So this is why I am subtracting. I know it seemed a little bit weird to start with, or it may have, but that's the logic. It's really just you take the area, the total area, and then you just subtract out the area that you don't want, and that will tell you, yeah, and that'll tell you the bounded area, the area between them. All right, so if you have any questions from other tests, make sure to leave a comment, and I'll make a video with a solution. With that said, if you enjoyed the video, leave a like and subscribe. This has been Investigative Math, and I will see you next time.